Okay, so for this question, basically this is from topic 3 practice set 2. So the angle theta is subtended by a minor circular arc AB of fixed radius 5 cm, increasing at a constant rate of alpha radian per second. And I want to find the rate of change of the area of the minor segment ACB at the instance when the area of the triangle OAB is 7.5 cm squared. Okay, so how do we go about doing this? This is a connected rate of change question. So when we are doing this, we identify that there are three derivatives that we will be looking for. So one of which will be given. So if we observe the question and read the question in detail, and we try to look at this part where they are given to us, where the angle theta is increasing at a constant rate of alpha radian per second. This is also telling us that probably what we are given. Just give me a second, let me erase this. Okay, so what we are given would be that the alpha, why is it so big? Okay, so it all works out. The alpha dt is equals to alpha radian per second. Okay, so this is given to us. So what is are we supposed to find, or what's the one that gets us the marks? Would probably be here. Looking in this, the hint will be here, where we are supposed to find the rate of change of the area of the minor segment. So what is this asking for? Probably this is asking for, because we are asking for rate of change of the area, right? Area. So I mean, for simplicity, let's just use A. So probably what we are looking for is dA dt. This is the one because they ask for the rate of change of the area. Okay, so then after that, what are we asked to what's hidden? Remember, there's always the third one that's hidden. Is the part where we actually need to do the re-expression and the differentiation, the one with the most work. Probably if you consider just looking at the three derivatives, you can see that the third one, I mean, if we are supposed to find dA dt, and this is the theta dt, the third derivative that we probably will need will be likely dA d theta, which is hidden over here. So the third derivative that's hidden will probably be dA d theta. Alright, so without further ado, we will need to find dA d theta. So if we need dA d theta, we first need to have an area, right, that we can differentiate with respect to theta. Right, so we have an area here, we need to have an area that is in terms of theta. Right, we have to have an area in terms of theta in order for us to go about to a differentiation. So we have A as a function of theta, then we can do the differentiation. Also, let's look at what the area we are finding for. The area here refers to the area of the minor segment. Alright, now if we use the circular measure formulas, we know that the area of a segment, right, basically A should be equals to half of r square theta. This is the area of the sector. Subtract away half r square sine theta. So this is basically the formula for the area of a segment. Okay, for the area of a minor segment. Okay, so we know that this is the formula that we need. Alright, so then after that, I mean, we do need to go ahead to calculate how do we need to go about differentiating this. But before we differentiate this, we do have to fill in whatever constants we can. Now, one of the things given to us is that the radius is fixed, which is 5. So when the radius is fixed at 5, okay, when the radius is fixed at 5, then, so just give me a while. Okay, when the radius is fixed at 5, okay, so then what we need to do is we can substitute in 5. In this case, it will be half of 5 square theta minus sine theta. Alright, which is the same as 25 over 2 sine theta subtract away sine theta here. Alright, so this is our A. So you can see that I actually have my A in terms of theta, so I'm good to go. Right, I have A in terms of theta, which I'm good to go. So and if I do my dA d theta here, my dA d theta would be none other than just 25 over 2. If I differentiate with respect to theta, theta is going to give me 1, and sine theta, when they're differentiated, is just going to give me cosine theta here. Okay. Now after that, what do we do next is we now look at substituting the values here. I mean, we have the numerical value for us to start is that the area of the triangle OAB is 7.5 cm squared, right? So if we know this, when the area of the triangle OAB is 7.5 cm squared, right? When this is given to us, what are we supposed to make out of it? Now OAB here, remember that this refers to this section over here. Alright, now the area of this triangle is 7.5 cm squared. What does that give us? It actually can give us a lot. Now, we know that the area of triangle OAB is actually also half AB sine C, alright, which is equals to 7.5. And we all know that this is just an area of a triangle, half AB sine C. And AB here basically refers to 5 because the A and B here is none other than the sides of the triangle. So AB half AB sine C. Okay, so from here, right, let's calculate this. 5 squared is 25 over 2. Sine theta equals to 7.5. Now this will allow you to obtain that sine theta is 7.5 over 25 over 2, which is just simply 3 over 5. Okay? So then with sine theta, right, how do we obtain the derivative? Okay, so now let's hold a bit, okay, sine theta. Now let's form the rate of change equation. Sometimes you will find that you are doing this, so dA d theta dt, right? I'm just using this. Okay, is d theta dt, which is alpha. Just note that, let me just write it down so you can see. It will be d theta dt multiplied by dA d theta. Okay, we note that this is the one that we're supposed to find. It gives us the marks. This is the one that is given. Sorry, let me just put down given. This is the one that we have found after all the work. We have done the differentiation as hiding. So dA dt will be d theta dt. D theta dt is alpha multiplied by dA d theta. Now what is dA d theta? dA d theta will be basically, I'm taking this here, 25 over 2, 1 minus cosine theta. Alright, and you notice that, of course, the numerical value we need to substitute in will be this cosine theta. We have to sub a numerical value into this cosine theta because it can't be an unknown, right? So what is the cosine theta? Now remember that this happens when the area of the triangle is 7.5. Now the area of the triangle being 7.5, it tells you that sine theta will be 3 over 5. So how do you use this sine theta to calculate what is the cosine theta? Very easy. Now just use a very simple right angle triangle. I mean, if you consider that by right, I mean, if sine theta is 3 over 5, let's assume that okay, with the basic angle, sine alpha would also be 3 over 5. Okay, so if we consider the basic angle triangle, then this will be 3 opposite over hypotenuse, and this will be 4. So it will tell you that cosine alpha is 4 over 5. What does that mean? It doesn't mean that cosine theta will be straight away 4 over 5. So it can mean that, yes, first one possibility is cosine theta is 4 over 5. It can also mean that cosine theta can be also negative 4 over 5. Right? Why do I say so? It's because if you consider that this is a minor segment, if this is a minor segment, right, your theta, right, it can be a cube. or it can also be obtuse. All right, it can also be acute or obtuse. What does this? How does this affect you? Is if it's in acute, it means that your theta will be in quadrant 1. If it is obtuse, it could be quadrant 2, and quadrant 1 means that quadrant 1 means that your cosine theta will be positive. Quadrant 2 will suggest that your cosine theta is negative, which is why this question is relatively challenging, because there are two sets of answers for you to consider. Okay, so now from here, this is my dA dt. You can see that my dA dt can either be in two scenarios. It can be alpha multiplied by 25 over 2, 1 minus 4 over 5. Okay, so I can put cosine as 4 over 5 on the assumption if theta is acute. Alright, or I can say that it's basically alpha times 25 over 2, 1 minus the negative of 4 over 5 if theta is obtuse. So you realize that this dA dt is not so easy to find, because there are two sets of answers. Alright, so just simplify this, and I believe the final answer you have is that this should be 5 alpha over 2 if theta is acute, and finally, this answer will be 45 alpha over 2 if theta is obtuse. Right, so that's all for this question. Thank you, and I hope you enjoyed the video.